So, my dear students, we have seen about SR latch and we have found that when S is equal to 1, R is equal to 1, we are getting Q is equals to Q bar. So, this is an issue for us in the SR latch when Q is equal to Q bar, okay, which is not correct. What exactly Q bar? If I give an inverter, if I give the input to Q, input as Q as an input to the inverter, I will get Q bar as an output. So, never Q is equivalent to Q bar. That is what exactly we know. But what happened in SR latch is when S is equals to 1 and R is equals to 1, we have proved that Q is equal to Q bar. So, as this is not possible, okay, and this set of inputs is undefined, we say it is undefined, okay, and we always avoid using S is equal to 1, R is equal to 1 in this circuit. Okay. Let us suppose S is equal to 0, R is equal to 0 is given to this circuit. From the fundamental operation of SR latch, okay, let us suppose initially this is also 0, 0 0 output will be 1, 1 0 output will be 0, or for 0 0 input, okay, let us suppose this is 0. What exactly I mean to say is this is 0. What I can do is just I will erase it and we will look into it. So, when 0 0 is given, what exactly that may happen is this may be 0, this will become 1 and this will become 0. So, what exactly happens is it is going to oscillate. What is that oscillate is? It will be moving from 1 to 0 and 0 to 1. Okay. So, this is what exactly the issue. That is the reason why we never apply S is equal to R is equal to 1 in SR latch. So, it is an issue. This issue we need to address. To address this, we will come up with a new circuitry that we are going to see the due course of time. Now, let us we can look into it how exactly it is going to behave for a particular pattern of inputs if at all I give it to this latch, okay, and we can analyze this circuit, okay, with respect to a particular set of inputs that we are giving to it and we can check it out. So, what is that is, see here how your flip flop outputs are oscillating as shown here with respect to the diagram. When you are giving 0 0, we are getting output as 1 0. When you give 1 1, we are getting output as 0 0. When you are giving once again 0 0, we are getting output as 1 1. Okay. Then you are getting 0 0. So, if you look at Q 1 0 1 0 1 0, if you go on changing from 0 0 1 1 0 0 1 1, your Q is go on oscillating. So, this is the problem in case of SR latch, right. Now, let us look at SR latch using NAND gates. The way we have discussed with respect to what is that SR latch using NOR gates, now we are trying to discuss with respect to NAND gates. Okay, similar circuit, only in place of NOR we are using NAND. So, if you know the NAND operation, then we can understand SR latch using NAND. What is NAND gate? How it works? Let us say A, B are inputs and Y is output. How it will look like? A, B inputs, Y output, 0 0 0 1 1 0 1 1. So, when one of the like AND gate, you know, AND gate followed by NOT gate is NAND gate. So, when 1 1 output is 1, now in this case it is 0, for rest of the cases it is 1. So, what I can say is when one of the input is 0, output is 1. When both the inputs are 1, then only output is 0. So, what I can say from this table is NAND gate functionality in single statement: if one of the inputs is 0, output is 1. If one of the inputs is 0, output is 1. Okay? This is how we can proceed with. So, what we try to do is we will analyze this circuit with respect to set and reset. Let us say S is equals to 1, R is equal to 0. When S is equals to 1, when one of the input is 1, can I say anything? I can't say anything. If one of the input is 0, I can say something. That is that if one of the input is 0, output is 1. So, this is 1. When this is 1 and this is 1, 1 input output is 0. So, this is 0. So, when S is equals to 1, R is equals to 0, S is equals to 1, R is equals to 0, Q becomes 0, Q bar becomes 1. Is this clear? Now, let us make both the inputs 1. You just do not change S, but you make R equal to 1. Let us make the analysis. Now, this it was 0, now same thing is 0 here, 1 0, 1 0, output is 1. It was 1, now it is also 1, so no change in Q bar. Now, when this is 1 and this is also 1, now this is 1, 1 1, output is 0, it was 0, it is same thing. So, when I keep S as it is, but where I change R from 0 to 1, still there is no change in the values of 0, the values of Q and Q bar. Now, if you look at S is equals to 1, when S is equals to 1, what is set reset flip flop generally? Set reset flip flop, how it works is like this: set is equals to 1 should be Q is equals to 1, but what is it is making? Q is equals to 0, that means active low latching. So, SR flip flop using NAND gates is also known as active low SR latch, because when S is 1, I am expecting Q is equals to 1, Q bar is equal to 0, but it is giving in reverse. So, it is called active low SR latch. Okay. Now, let us see. Now, what exactly that I am trying to do is, I try to work with the flip flop for these combinations. What I do is, I will make S is equals to 0, R is equals to 1. So, to make this all clear, let me erase what is there here, then let us proceed with the discussion. Now, just I am starting with fresh. Just what I do is, I take S is equals to 0, R is equals to 1, S is equals to 0, R is equals to 1. Okay. When one of the inputs is 1, can I say anything? No. For NAND gate, if one of the input is 0, output is 1. So, here output is 1. When this is 1 and this is also 1, 1 1, output is 0. So, with S is equals to 0, R is equals to 1, Q bar is 0, Q is 1. Now, what I do is, I do not change R value, I will make, what I try to do is, I do not change R value, that means R is as it is, I will change S to 1. So, I will change S to 1. So, it is 1, 1, 1, 0, it was 0, this is 0 and this is 1. So, 0, 1, one of the inputs is 0, output is 1. Is there any change? No change in the output. So, when S is changed from 0 to 1, where R kept from same value 1 to 1 itself, then there is no change in Q. So, when S is equals to 1, R is equal to 1, there is no change. Okay. And similarly, when S is equals to 1, R is equals to 1, there is no change. Okay. So, here are the certain no change cases. What is that no change is, S is equals to 1, R is equal to 1. So, that is what exactly you need to understand here. There is a no change here also no change, okay, no change. Now what is the last case that we try to discuss here is, let us apply both of them zeros. As I told you, it is active low latch. You want reset and same time set. Okay, if it is active high, if both the inputs are 1 1, you want set reset. As it is active low 0 0, you want to set, you want to reset, not possible. Now let us see what is going to happen with respect to the circuit. If any one of the input is 0, when any one of the input is 0, what exactly the circuit operation with respect to NAND gate? It is very clear. Okay, when both are zeros, we know any one of the input is 0, output is 1. So from that context, what I can say is, this output is 1, this output is 1, this output is also 1. Once again I am proving that when S is equals to 0, R is equals to 0, what I am getting is Q is equals to Q bar. Okay. So on the whole, we have understood, what we have understood is, we have understood SR latch, okay, active high logic, SR latch, active low logic. Active low logic is made up of NAND gates. Active high logic is made up of NOR gates. Okay, fine, we will stop here.